Okay, in this video we're going to learn about similar figures. We've learned about congruent figures, but now they're just going to be similar, okay? So they're not going to be congruent, but they're going to have some things in common. So these are similar, and these figures are not. So what do you notice about something that is similar versus something that is not? Hopefully you said they're the same shape in your head, okay? Notice they all have the same angles as well. So let's imagine this to be a rectangle. I know I've got 90 degrees, whether I make something big or small. We've kind of covered that in the past. But these shapes are not similar, so they have to be the exact same shape, just bigger or smaller, okay? So similar figures are two polygons are similar if and only if the corresponding angles are congruent. And again, corresponding just means the same spot in a different shape. And the measures of the corresponding sides are proportional. So the angles are congruent, because remember, angles don't change whether you make something big or small. But the sides are going to be proportional. So we're going to make something larger or smaller around the same proportion, so the same fraction, okay? So for similar, we now have a tilde mark. So remember, congruent had an equal sign with that on top. Well, now we're taking out the equalness part of it and just left with the top, okay? So that is the symbol for similarity, okay? So let's look at some examples. So if I have ABC is similar to triangle DEF, let me go ahead and draw ABC. Let's draw a larger DEF. And let's pretend Ms. Callahan's awesome at drawing the exact same shape. Okay. So again, the corresponding angles are congruent. Okay. So A is going to be congruent to angle D. I know B is going to be congruent to angle E. And then lastly, I know C is going to be congruent to angle F. So that's pretty much the same from Module 3. And again, you can look at that similarity statement and notice that if they're in the corresponding positions, they're similar. Now with ratios, again, they're going to have the same ratio. So we're going to have the same fraction describing the sides. So let's talk about AB. AB is going to have the same ratio as DE. Okay? And then BC is going to have the same ratio as EF. And then lastly, we'll go AC is going to have the same ratio as DF. So it's the same, parts about congruent triangles. They're in the same order, but now we're just looking at ratios instead of them being the exact same. So scale factor, remember that from dilations. If the scale factor is larger than 1, we know it's going to be getting larger, so it's called an enlargement. So if your scale factor is smaller than 1, so like typically a fraction, like 2/3, that's going to be a reduction. Okay, so if you see a shape getting smaller, you would expect a scale factor of a fraction. So I would expect my scale factor of my shape to be larger than 1. Okay. All right. So using a scale factor to find the dimensions of another figure. So I want to use a scale factor of 2 to figure out what this shape is. Well, you guessed it, times everything by 2. Okay. So 7 times 2 is 14. So the legs of the trapezoid are going to be 14. 9.5 times 2 is going to be 19. And then 4.5 times 2 is going to be 9. Okay. Lastly, scale factor of a half. Again, that's the same as dividing by 2. So I need to divide all those numbers by 2. So I get 5 and 5, 4 and 4, 3 and 3. Okay. Again, if I was going from the smaller shape to the larger shape, that'd be multiplying by 2. If If I was going from the larger shape to the smaller shape, the scale factor would be 1/2 because I divided. Okay, so let me know if you have any questions on scale factors. Otherwise, I'm going to jump into some notes. So similar figures are enlargements or reductions of each other. The amount of enlargement or the reduction needed to change a figure is called the similarity ratio. The ratio of the lengths of the corresponding sides is the scale factor. Okay, so determine if the polygons are similar and show work to justify your answer. Okay, so these look like the same shape, so far so good, but now I need to make sure that they're in the same proportion. So to do that, let me check this left side because this side obviously should be the same. So I'm going to say 12 divided by 9. And I know that can be divisible by 3, so that fraction would be 4/3. Okay, so going from the bottom shape to the larger shape was a 4/3 ratio. So now let's just check to make sure that's true here and here. Okay, so I went large to small before, so I need to do that again and do 16/12. So if I divide each of those by 4, I should get 4/3. So hey, it worked out. I had the same proportion. Okay, so those two shapes are going to be similar. Again, I didn't check all sides because I knew opposite sides were the same. So they're similar because they have the same scale factor. Okay. So again, if you were going from the small shape to the large shape, 4/3 would be your scale factor. It would be 3/4 if you were going from the larger to the smaller. Okay. All right, moving on. Let me check the smallest number up in the top one and the smallest number down here. Okay. So let's say 6/12 is going to be 1/2. Awesome. Then you're going to check your largest number up here with your largest number down here. So let's go 8/24. If I reduce that, I would get 1/3. Okay, so these are not similar. Okay, they've got to have the same ratio or proportion. And then lastly, number 3, you can just look at that and say they're not similar because they're not the same shape. Okay, you got to have the exact same shape for it to be similar. Okay, all right. So that's how you check if something is similar. Now let's work on setting a proportion to solve something given that we are told they're similar. Okay, so it tells me that these triangles are similar. Okay, so that means I know there's some proportion. Let me just make sure this triangle is not flipped around. So I know that JH is the same as ML based off that congruent statement. I know HI and LN are the same. And then lastly, that would leave my third side similar. Okay, so write a proportion for the corresponding sides. So let's go ahead and we'll start off with JH. So JH over ML is going to be proportional to pick two other sides. HI over LN, which is also going to be proportional to my last side. We'll say JI and then MN. Okay, so this is how you set up a proportion talking about the corresponding sides. So now we can solve for X and Y. Now you need to pick a side that gives you two numbers because that's my proportion. So I'm going to be using 50 over 30 every time. Okay, now let's solve for X first. So X is going to be up here. And this is its corresponding side. So again, I went from the larger to the smaller. So I need to make sure I go back to the larger and put it on top. And the smaller side will go on bottom. That's the most common mistake, is if you go from large to small, you can't go small to large. They've got to be in the same order. So once you set that up, all you do is cross multiply. So you should get 750. Remember, when you're multiplying two terms, it's like the distributive property. So you would get 60x minus 90 equals 750. Add 90. 840 equals 60. Divide by 60. X is going to equal 14. Okay. All right, lastly, solve for y. So here's my y. But again, I'm going to use 50 over 30 again. So I went from top to bottom, so now go top to bottom. So 45 is going to be on top, y is going to be on bottom. Again, you could flip the fractions, you would still get the same thing. So when you cross multiply, you would get 1,350 equals 50y. Divide by 50, and y is going to equal 27. Okay? So again, just make sure you're consistent with whether you're going from the larger shape to the smaller shape or the smaller shape to the larger shape. Okay? All right, one more thing. Look at one more example. I know ABCD is similar to WXYZ. So I want to know the similarity ratio of this first shape to this second shape. Okay? So I notice it's going large to small. Okay? So you kind of do the opposite, and you do the small shape over the original, okay? So your formula is new shape over the old shape, okay? So that would give me 1/3. So my similarity ratio is 1 to 3, and the scale factor is 1/3, okay? So you're going to expect the bigger number to be the right side because the shape got smaller. And you're going to expect a fraction. So again, use this whole new shape over old shape. Or you could say the second shape to the first one to find your scale factor. Label the missing sides. You could kind of do some shortcuts in your head. I know from going from a 9 to a 3, you got to divide by 3. So do the same thing over here. So this side is a 3. This side's 4 because it's opposite. Or you could have also said 4 divided by 3 is or 12 divided by 3 is a 4. All right. One more example. Actually, why don't you guys try this one on your own, and then we'll go over it. So press pause and try it on your own. So you went from a small shape to a large shape. So you're going to expect something to be bigger than a 1. So again, do the new shape of the old shape. So I did 15 over 3 and got 5. So I knew my scale factor was a 5, which means my similarity ratio is 5 to 1 because 5 divided by 1 is just a 5. Okay? So basically I times everything in the small shape by 5 to get the lengths of the larger shape. And then something cool to notice is when you add up the perimeter of the first shape and you add up the perimeter of the second shape, something you noticed, you can also do the little similarity ratio for the perimeter, okay? Because 14 times 5 gives you 70. So the perimeter ratio still stays the same, which makes sense. So the ratio for the perimeter is going to be 5 to 1. Because they got larger. Cool. So those are how you find missing sides using similarity statements and how you prove something is similar or not. So if you have any questions, let me know. Otherwise, thanks for watching.